All right, so we were talking about what the a value does in our graphs for parabolas and quadratic functions. So as you can see, I have some equations that I set up over here. So our parent graph is this one right here, the x squared. That's with no numbers involved in it. That's what you start off with as a basic function. This is the red line that you see right here. And then when you change the a value a few different ways, it changes it different aspects. So you can see that the blue line, this right here, this parabola is a 3x squared. And what that means is that it is obviously greater than 1 for the a value. So it's going to stretch that graph out. It's going to make it skinnier looking, and that it keeps it the same direction though. And then when we look at the green graph that you see right here, that green graph is a half. So a half, anything greater than 0 but less than 1, what that does is it compresses it and it kind of widens it. So all of the graphs, as you can see, they're all the same way, the same direction. So if the a's are positive, then that's what it does with those things. Now, when it's negative, it does the same thing as far as the 3, if it's bigger than 1, it widens it, it stretches it, or sorry, it doesn't widen it, skinnies it. It makes it thinner and it will stretch it out. The negative in front of something, what that does, what you can see that's over here, this is a negative half x squared. That actually just flips it upside down. So that's a reflection. So there's different properties that you guys look at when you're talking about different equations. That's what we're looking at as far as the a values go. So that's the differences with the a values. I'm going to throw another standard form so you can see what it does. I'm just going to put just a basic x squared, no coefficient for a, so we're just going to leave that as a basic. So it's going to start off the same way as the normal stuff. And then I'm just going to throw a few additional points on here. So we got a whole equation here with trinomial. And as you can see, what it does here is now it's over here. So it's shifted this over to the left-hand side. But what thing that you're going to really notice with this is that the c value, this is what the c value does right here, that +6. If you look at this graph and you follow it up, what do you notice about the c value, 6? That tells you what your y-intercept is. So that's what the c value does with our graphs. And so you can see what that will help us with. As far as the b value, a lot of people ask me, like, what's the b value, the middle value here, the trinomial? You can see that it's done a little shifting over to the left, like I said. What that does is it changes where your vertex location is, and it shifts the graph left or right, depending upon where you're going. So if it's a positive, it's going to shift it over to the left. If it's negative, it's going to shift it over to the right. I'm going to do the same equation. And as you can see, when I do this, I'm plugging it in, and we're going to do the same basic type thing. So you can kind of see the same motion here. And as you can see with this one, it's getting confusing here, but you can see that it shifted it over to the right. If you want more questions like these, you can find them on my YouTube, Instagram, and TikTok at YouWantAlgebra. All of these are going to be located in the quadratic functions section. Don't forget to like, share, and follow for more.